So welcome back. So in today's class, we'll be discussing about phases of compilers. So in the previous session, I guess it's clear what are the different models of compiler was, or the question will be general model of a compiler. So we have discussed what is meant by lexical analysis, syntax analysis, interpretation, machine independent optimization, and storage assignment, code generation, and assembly and output. This was been discussed in the previous one. So in this session, we'll see what are the databases that are involved inside this general model of the compilers. These databases are not a rocket science thing. It is just inside this compiler diagram, general model of the compiler diagram. If you have taken a look, the first phase was lexical analysis. So in lexical analysis, what all jobs it does. So first one, any compilers, its work is to take the source code, convert that into an assembly code so that it can be used. That is conversion of your source code to an object code, or in case of assembly language, assembly code we are going to generate. So first source code, that is nothing but your user program itself. So your in first phase, that is lexical analysis phase, you'll be having mainly three things to do. That is your generating the tokens and uniform symbols. So uniform symbol, it is a part of your tokens itself. So in tokens, it is a combination of literals, your identifiers. So all this comes under the lexical phase itself. Apart from that, you have a terminal table, very important 2 mark question. So terminal table, it is nothing but it's a permanent table. It will display all the key elements. So in short, I can tell it is a special symbols of whichever language or whichever code that has been represented in a specific symbolic form, those in which it has a special symbols, that is called as your terminal table. This terminal table is considered as a permanent table. If you take identifier table, it is a temporary storage. It is used to allocate the storage. This is the job of permanent identifiers. So if I'm having some identifier variable that has been, so that particular value will be stored under that identifier name. That is the use of identifier table. So literal table, it contains all the constants that is used inside the program, which will not change during your execution. Reductions, I think you are very clear with that. So it will be having some patterns or some equations or some expressions in the form of in a particular syntax or with along with uniform symbols that will be reduced. So next, after reductions, you are going to construct the matrix. So matrix is the where in which phase we are constructing the matrix. In the intermediate form, that phase we are constructing the matrix. So based on the matrix, we are going to generate the code. Code will be generated, or I can call that as code productions. So once the codes are generated, then the assembly language version of the code will be created so that you will get your object code. So this object code is given to this relocatable or reallocatable or locatable. This will be considered as the final input for the loaders. So we'll get in detail about the phases of compilers. So as it is similar, the content there is no change, though the phases or the model of the compiler. So in phases of the compiler, first thing, we have totally 7 phases. So 7 phases are similar, like earlier we learned as lexical analysis, syntax analysis. Here we'll be seeing it as lexical phase, syntax phase. So we'll see each and every phase. Similarly, we have 7 phases in phases of the compiler as well. So I told in this chapter we have 3 sets of question, but all the 3 sounds the same. First one is general model of the compiler, or I can call that as structure of the compiler. There everything will be analysis, lexical analysis, syntax analysis. Whereas phases of compiler, it will be called as syntax phase and lexical phase. Similarly, intermediate phase as such is goes on. I have just jotted only the key points which you have to learn. So first phase is your lexical phase. So in lexical phase, it is going to do 3 jobs, the same content. So lexical phase, it is going to divide the source program into tokens, uniform symbols, the same thing. Once again, we will be learning in different perception. So in source program, that is your source program is divided into basic elements called as tokens. So from that tokens, you're going to identify which are all the constants, which is an identifier. Constants will be mapped to literal table, and identifier into identifier table. Then we are going to build the uniform symbol table, or it can be called as uniform table as well. So in lexical phase, we have 5 databases. So 5 databases are nothing but which are involved inside the process in lexical phase. So 5 databases. The first one is as usual source program. The next one we have terminal table. As we have seen in the previous one databases, same thing. So terminal table, it is a permanent table, or here I can call it as permanent database. So it is going to store what is the symbol you have used, and what indicator you have used, and what precedence you have applied. Precedence in the sense whether it is a multiplication, division, or addition. In that way, which precedence you have applied is also taken care in your terminal table. So next, third database we have is literal table. So literal table, it is created in to describe if you have any constants in the program. Also, I can tell in short, if you have a binary value or declared some value as fixed is 31, that is a line in the coding fixed of 31, it means it is a constant, it will not change during your execution. So this is mapped to your literal table. Next we have identifier table. Next your database identifier table. So it is created, the main purpose of it is to identify what all the variables that is used inside your source program, and it will have all the data attributes and address where the identifiers are mapped, where it is exactly stored. Suppose I have some variable called a, b, or some variable that is an identifier, it will have the details where this a is being stored. Next we have uniform symbol table. It is used to represent what all string or tokens you have used. If one uniform symbol is used for every token in the program, we'll have different uniform symbols. So in which table, what is the number of that particular value, it is stored inside your uniform symbol table. So next we have syntax phase. So syntax phase, the main job of syntax phase is it is used to recognize what all construct, what all the reductions we have, what all the action routines it is going to perform. Like previous lexical phase, we have 5 databases. Here we have 4 databases. So first one database is your uniform symbol table is the first database. It is similar to the previous lexical analysis. So this uniform symbol table is nothing but it is already created in the lexical phase, that has been taken inside your syntax phase. So here it is uniform symbol is taken, it will from the lexical phase as the input. So whatever output you get it in the lexical phase and the uniform symbol table, here it is the source of input. So from this input will be stored inside the stack, using some syntax so that it can be interpreted for in the interpretation next phase I can use it. So what is meant by stack database? It is a collection of all these uniform symbols that you're going to work. It means you have start minus finish, all these are called as the start, finish, all these are called as your identifier. So when it becomes an expression, this is your uniform symbol. So I need to store that inside the stack. So we have some priority, which suppose bracket comes first, multiplication comes first. So in which order they are supposed to be piled inside your stack, it has to be decided. So generally stack follows last in first out manner. So top of the stack refers to most recently entered value. Bottom of the stack will have the oldest entry, as you know that. So this I'm going to arrange the symbols. So which symbol will be on the top, which symbol will be on the bottom will be decided in the stack phase. Next we have reductions. So reduction, it contains some syntax rules. using that rules I'm going to reduce them. So based on that I'll be labeling the stack into new names, either as some old top of the stack or new top of the stack, and what are the action routines, which one will take the top of the stack, and next what will be the reduction value. With an example I'll tell you what is meant by reduction. Reduction is nothing but if I'm writing C is equal to A plus B, this is an expanded uniform symbol. If I'm going to write C is, I'm assigning some value for A and B. Now C is equal to 1 plus 1, if it is 2, it is reduction, it is reduced. The C is equal to 2, this is called as reduction. We'll move to the next phase. So next phase is about interpretation phase. So interpretation phase, this is a place where you're going to construct whatever uniform symbols you have, you're going to make them into an matrix like format, and that matrix will be used in the next phase called code generation or machine independent or dependent optimization. So interpretation phase, it's a collection of all the routines so far whatever we have done. So it is a precisely I can call this interpretation phase as a matrix of parse tree generation. So we have some databases in interpretation like uniform symbol table. The previous one's output is taken here as the input, and here also we have this stack, because that is a place where you're going to store this symbols or uniform table. Here we have an identifier table. The main purpose of this identifier table is this will help you to assign value and enter the address of this particular attribute which has been used inside the lexical phase, so that it is similar to what it was doing in the lexical phase. The same thing has been carried out. So this identifier value should not get changed when you go from one phase to another. Suppose one identifier is start, if it is stored in the location 100, it should not change as you move from one phase to another. Next we have matrix. So the primary main important thing in interpretation is the matrix representation. As you know, we are drawing an parse tree and mapping that according to matrix line number. That happens in the interpretation phase, and temporarily we are storing this value inside a table called temporary storage table, just before making this code an optimized one. Next we have machine dependent optimization and machine independent optimization. So generally compiler can perform two types of optimization. So machine dependent optimization means it is related to the instruction that get generated, so that the code can be generated by itself. Independent is it happens in a separate phase. So this dependent optimization and independent optimization I'll be discussing in the live class. Now I'm going only with the theory part. So what is this matrix optimization? This problem will be solved in the live class, upcoming live classes. So next phase we have storage assignment. So storage assignment is nothing but after doing this code optimizing the code. Optimizing the code is nothing but reducing the number of lines in the code by doing the method of substituting the expression. Next, with the previous general model of the computer, you would have learned about storage classes. Here it is storage assignment. We have some databases like identifier table, and we have temporary storage table, literal table, and matrix. So identifier table, same like what you have taken from the lexical analysis phase. If you have an array, if you have a storage class where this particular value is stored, that address keeps on updated inside an identifier table. It is the main thing about identifier table is it will have all the attributes from lexical analysis phase. It will be taken to the syntax phase, then it will be taken to the interpretation phase. From interpretation I will be taking the attribute to the storage assignment phase. Clear? So next, from the storage assignment phase I have literal table. It also this is very important inside the storage assignment. It assigns all the literal address and it places the entry inside the matrix, any constant value, and it allocates some storage to that value. Matrix, it does the same job as the previous one. Any one matrix you learn properly, in only the context will changes. Under storage assignment, the matrix entries are placed and we are making sure that they have their own storage and their literals are being identified. This is what is happening in storage assignment. Next phase is we are going to generate the code generation, the last phase. Clear? So once a code is being generated, the code generation is nothing but your assembly phase, or the assembly, the place where you're going to get the output of the program. Yes, with this your syllabus is completed. Now we'll be having some revision classes and passes of the compiler. This pass 1, pass 2, pass 3, pass n minus 2, pass n minus 1, pass n of the compiler. The same thing again it will go: lexic analysis phase and syntax optimization, storage assignment, code generation and assembly phase. So at this I'll wind up the session. Thank you guys. More of classes will be on. We'll be having revision classes. During that time, in detail, I'll be discussing about this.